Hi again. In this video, we're going to go through the steps for a theoretical hypothesis test for comparing two proportions. Okay, so we've done it by simulation. Now we're going to look at the theoretical test. Okay. So our null hypothesis is that there's no difference, right? That P1 is equal to P2. There's no difference in the groups. So remember how we set up our null, we set up our test assuming the null is true. Okay, so we have to do something a little interesting with a test of two proportions. What we do is we combine both groups together to get something called a pooled or combined sample proportion. Okay, so I'm calling it here P hat C, which means I can't use P hat C for the control group anymore. A little bit of a challenge there. You'll see it sometimes called the pooled, like maybe P hat P or another symbol as well. Okay, so if there really is no difference in the groups, then we want to take all of the successes over all of the cases. Okay, and so let me show you again back in our dolphin example. This is where I mentioned the 13 was going to come up again. The total improved were the 10 in the dolphin group and the 10 in the control group, and that total is 13 out of 30. So I'm going to write P hat combined, since I've already have a P hat C on this page. P hat combined is 13 out of 30. Okay, and we'll go through this whole theoretical test. But first I want to go through all the steps. Okay, so essentially that's what we did there, is the successes for each group over the total. That's the 13 out of 30. If you don't have the counts, this is a different formula you can use if you have the proportions. Then to get the counts, we would need to multiply the proportions by each sample size to estimate, as might be rounded, so it might be an estimate of the counts. Okay, so this is our P hat combined. Okay, so we need this for our null, we need this for our test statistic, because that is assuming there's no difference, so we just combine all the successes together. Okay, so let's go through our steps and you'll see how this comes up. Okay, just like you're used to, we want to get our p-value from the normal distribution, so we have to make sure these conditions are met to use the central limit theorem and the normal. Make sure we have that normal shape. Okay, so here's the steps for the hypothesis test with the normal distribution. This is called a z-test for difference of proportions in GeoGebra. Okay, so just like you're used to, we're going to write the null and alternate hypotheses. Okay, then we calculate this pooled or combined P hat C. Okay, and check all of the conditions which are listed below. We'll go through those. Okay, then we always want to write out our observed statistic. And in that case, our observed statistic would be P hat 1 minus P hat 2, or whatever letters you're using. This is all written in terms of 1s and 2s. And then calculate your test statistic. So remember, our test statistic is a z-score. It's how many standard errors from the null, which in this case is 0, how many standard errors away is the observed statistic. Okay, so we can get an idea of how usual or unusual that is. Okay, now this looks more complicated than with one proportion, but you can see we have our observed statistic right here, P hat 1 minus P hat 2, and the null is 0 because the difference is 0 in the null, that there's no difference. So you don't have to write that. I just wrote it to show you that we're using the the z-score formula. The statistic minus the mean divided by the standard error. And so this is a standard error formula that is based on that combined P hat C. Okay, so it looks a little different than we used for our confidence interval because we're not using the combined standard error for groups 1 and 2. We're using it based on this pooled p hat c. Okay, so square root p hat c q hat c times parentheses 1 over n1 plus 1 over n2. Okay. Then we can use the normal calculator with, of course, our standard normal, which is a mean of 0, and standard error of 1 to find the p-value. Just like you're used to, we'll compare the p-value with the significance level and determine whether the result is statistically significant. And just like you're used to, we're going to state the conclusion in context, including the p-value and whether we reject or fail to reject the null. Okay, so very similar steps, just the conditions might be slightly different and the test statistic has a new formula. So let's check out what our conditions are. Okay, this will be similar to our confidence interval for two groups. Individuals in each group and between groups must be independent of each other regarding the variable measured. Okay. Randomization. The data are from either 2 independent random samples or 2 randomly assigned groups. Okay. Large population, which applies if we're sampling without replacement. The population must be 10 times the size of each group. And again, it could be 1 population or 2 populations. So adjust for that in your wording. And then the success-failure condition. We should expect to have at least 10 successes and 10 failures in our data under the null hypothesis. Okay, so remember, we're assuming the null is true. So to check the success-failure condition, we're going to use the pooled p hat c. So n1 p hat c and n1 q hat c both have to be greater than or equal to 10, and also with the second sample size. Now, if our 2 groups are equal, then there's just one, they're the same. But if you do have 2 different sample sizes, we've got to check for both sample sizes. Okay, great. Those are all the steps and conditions, and let's go through the dolphin one in the next video. So I'll see you there.